Bismillahirrahmanirrahim. इंटीग्रेशन ऑफ द लाप्लास ट्रांसफॉर्म। तो इस वीडियो में हम लाप्लास ट्रांसफॉर्म की इंटीग्रेशन इंटीग्रेशन करेंगे। ये वाला फार्मूला डिराइव करेंगे कि द लाप्लास ट्रांसफॉर्म ऑफ एफ ऑफ टी ओवर टी is equal to integral from s to infinity f of tau d tau, where this is the Laplace transform of f of t, this f of t. Okay, let's start. Uh, let's prove. So we want to prove this relation. The Laplace transform of f of t over t is equal to integral from 0 to infinity e minus st f of t over t dt. Now I can write this integral as 0 to infinity, and I write this function in the integral form. Integral from s to infinity e minus tau t d tau f of t dt. We see that this, let evaluate this and see what the value of this integral is. So I'm doing here, if integral from s to infinity e minus tau t d tau. When we integrate with respect to tau, this will be minus exponential minus tau t over minus t from s to uh, infinity. Okay, so we see that this is equal to minus 0 on the upper limit, put tau infinity, so minus exponential minus infinity is 0 and plus e minus st over t. So this is exactly what we encircle here. Okay, so we write this encircle function in an integral form. Now we have to switch the integration of t and tau. This is Laplace transform of f of t over t is equal to, we knock out this integral of tau outside and in the integration of t inside. So this is minus tau t f of t dt, and the tau integral we take at the last. What we see in these brackets, this is the Laplace transform of f of t. So the Laplace transform of f of t over t is simply the integral from s to infinity, uh, the Laplace transform of f of t d tau. Simply we can write integral from s to infinity f of tau d tau. We see tau is a parameter here instead of s, and that is the required this is the required relation that the Laplace transform of f of t over t is simply integration from s to infinity the Laplace transform of f of t, which is f of tau d tau. So we proved this relation and we will use this in the next video. So what is the benefit of this relation? Okay, thank you. We will use this in the next